word of warning here, a lot of what we're going to do in this week's material is going to be built on somewhat abstract results with these things that we have called theorems. They're little provable facts of math that are very general and can be a little bit confusing for all the symbols, but usually they come from somewhat understandable places, or at least are meant to represent somewhat understandable things. Where the first one that we have, the remainder theorem, is built off of a thing called the division algorithm, where the division algorithm is essentially just saying that division is the reverse of multiplication. That if we have some value f, it can be written in terms of a smaller value d multiplied by some other smaller value q, along with some other value r that is smaller than both d and q, where this fits in terms of numbers or polynomials. That if we have some polynomial f, that we can write it in terms of d times q, the two polynomial factors, along with some remainder polynomial. But in particular, we get a result of this called the remainder theorem, where if we have that our function f, our polynomial f, is divided by x minus c, then we're going to end up having that the remainder there, the remainder value, is equal to f at c. And the reason why this happens is that if we take something like this, and we have that d of x is equal to x minus c, then by the division algorithm, we will have that f of x, which is equal to dx qx minus rx. So I know it sounds like drugs, but it's not. It's not, it's remainders. Don't worry about it. That's going to have the form x minus c times qx minus, it's not minus, why did I say minus? That should be plus. Getting a glare in there that's throwing me off. I mean, it could be minus, but that'll do something else. There we have that type of value, but in particular, if we evaluate this at c, we'll end up with f of c is equal to c minus c times q of c plus r of c. But because r has to be smaller in degree than both d and q, and in particular d is linear, that means r is just constant. So what we're going to end up having here is that f of c, f of x, f of c is equal to this thing, which dies because c minus c is 0, plus that thing, which is just a number, r. Hence, the remainder theorem. And this by itself, again, it's abstract. It doesn't seem very useful, but if we wanted to do that, we could talk about how if we evaluated our function from the last example at -2, we would get -135, the remainder value. But the best way that we can use this is when we have the value there, the remainder is 0, because that will help us identify factors, it will help us identify roots, and that's what we're going to finish this section talking about. We're talking about how you can take this special case and look at an even more special case with what is called the factor theorem.